So hello everybody and welcome to my talk, Adopting a Reactive Mindset. My name is Donnie Walls. I am an iOS engineer over at Disney Streaming Services where I work on our SDK that powers the Disney Plus app and many other things on several of Apple's platforms. In my spare time, I blog a lot and I also write books. I'm currently working on a book on core data. And I have published a book about Combine earlier this year. In this talk, we're going to focus a lot on Combine. So if you like this talk or you want to learn more about Combine after this talk, make sure to pick up the book at practicalcombine.com. Now, the agenda for today is as follows. We're going to take a look at functional reactive programming first. We're going to learn what it is. We're going to dissect it. We're going to look at functional programming, reactive programming all separately. Next, we're going to look at a simple network request. I find that networking is a very good place to start learning Combine. It's usually very straightforward to get started in your networking layer, and it's overall just a good example of what reactive programming can be like. Then we're going to build something more complex, also based on networking, simply to keep that flow going and to make sure that we can cover a ton of ground in a very short amount of time. Now, we're also going to learn what the most important building blocks of functional reactive programming are. And I find that if you want to adopt that reactive mindset, understanding these fundamental building blocks and knowing how to integrate them in Combine is absolutely essential. So when I first started learning functional reactive programming, I was pretty confused. I did not find it easy to get started with at all. So when I asked other people, like, how do I do functional reactive programming? What is it? How does it work? They would say things like, it's basically just streams, or it's about values over time. And that kind of frustrated me because it doesn't tell me anything about what functional reactive programming is. I mean, once you've learned it, it kind of makes sense that people would say this, but while you're learning it, it's just not very helpful. And all it really did for me was make me think that this stuff is pretty hard. But I'm here to tell you that it doesn't have to be that hard. It can actually be fairly straightforward as long as you ease yourself into it and not try to dive in all at once. So, as you would do with sort of a contrived word like functional reactive programming, we can pick it apart and take a look at the functional bits in functional reactive programming first, before we move on to look at the whole picture. So functional programming is something that we can do in Swift, and it's something that programmers have been doing for decades. Now let's look at some of the core principles of functional programming. Bear in mind that this isn't everything that functional programming is. It's not everything that functional programming does. It's just some of the things that I have found to be important and key to the functional programming experience. So first of all, you're programming with functions instead of objects. So instead of capturing a lot of your functionality in classes and structs and inheritance structures and all that kind of stuff, you do a lot of your work in functions instead. Now what this means, I'll show you in a second, but that's just how functional programming is, and that's something that you really have to get used to at first. Functions in functional programming are supposed to be pure, and this is really important. Any function in the functional programming world should not operate on anything that was not explicitly passed to it. So you shouldn't apply side effects, like if you're in a struct calling a function, you shouldn't change state within that struct or class. Instead, you should take whatever was passed to you as a function and return something new. This makes functional programming highly repeatable and easy to test. Functional programming also uses something called higher order functions. Now, this is just a fancy word for functions that take closures or other functions as their input, like map in Swift, for example. And functional programming tends to be very composable. It means that you can often chain functions together and that kind of stuff. Now let's look at an example of functional programming in Swift. Map, for example, in Swift is a very good example of something that is borrowed or taken in from functional programming. Map is a pure function. It is defined on sequences and it takes every element of the sequence as its input. It's called for every element in the sequence and it produces a new output. Now, if you would mutate your array here, or if you would apply side effects inside of your map, you're doing it wrong, because map is supposed to be pure. It's supposed to take an input and produce an output. So in this case, we take an array of integers and take each element, return a string for that element to create a new array of strings. Now, if you are familiar with map and all that kind of things in Swift, you may have seen flat map as well. So if it would map over the same array of integers and return a new array of integers for each integer in the array, you would get an array with a level of nesting. So you get an array that contains different tiny arrays. However, if you would flat map instead of normal map over the same array of integers, you don't get an array that has arrays as its elements. You get an array that's flat. It only has a single level of nesting, which is just the base level, and you get an array that contains only integers, so 0, 1, 0, 1, 2, etc. I want you to remember flat map and how it takes nested arrays, or how it can loop over an array and then return new arrays, and how it flattens this into a single level of nesting. Right, keep that in mind, because it's going to make an appearance later in this talk. Take another good look at it, make sure you memorize it. Okay, so that's enough about functional programming. There's tons of other information about functional programming that we could talk about, but this is all we really need to know for now. The reactive bit in functional reactive programming is all about responding to changes. And when you think of changes, I want you to think of changes in a very broad way. A lot of things can be changes. For example, the user tapping a button can be a change. The user entering a geofence can be a change. The user scrolling can be a change. Network call completing can be a change. And sometimes you're only responding to a single change, and other times you're responding to many changes. A user scrolling could happen many times over the life cycle of your application, or a user tapping buttons will happen a lot. However, every network request that you make is only going to trigger once. A user entering a geofence is something that could happen once or could happen 20 times in the life cycle of your application. You just don't know. And eventually, the changes that you are receiving in reactive programming might stop. For example, if a user would turn off their location services, that would be a hard stop on receiving geofencing events. Or if the user would quit your app, that would be a hard stop on really any change inside of your application. However, a network call, for example, will simply execute once, then complete normally. After a network call has given you its response, there's really no point in the network call doing anything else because there's nothing else to do. Now, you notice that I'm using the word change here, but what I really mean is value. However, I usually start this explanation with change just because changes are slightly easier to grasp for people. But changes are often represented as values. The output of a network call is a value. A user entering a geofence, the geofence that they entered could be a value. Right? So that is really important in the reactive world. Things happen in your application, state changes value, and you want to receive these changes and respond to them somehow. And when these changes occur and when these values are generated, they are streamed to the receivers. So what that means is you don't go out and actively seek new values from objects that produce values, which are called publishers in Combine. And instead you wait until these values are passed to you by a publisher. Right? So they are streamed to you. That's what this whole streaming values is all about. Now let's take a quick look at an example of what this looks like. The first two lines of code on this slide are not interesting. I don't want you to read it all at once, by the way. We'll go over it. The first two lines are not very interesting. They just obtain a reference to a notification and to a notification center default. The main reason I did this is because otherwise all the code wouldn't fit on the slide. Now, the most interesting line is right here, or the first interesting line, I should say, where I capture a publisher. Right? I create a new publisher by asking the notification center for a certain publisher for a certain notification. And publishers are the objects in Combine that send changes to their subscribers. Publishers are also generic and strongly typed. So that means that a publisher has two generic arguments. One for its output type, which at the end of the chain that I'm showing you will be a CG rect. It could be anything, like the notification center publisher will publish notifications. And publishers also have a failure type. In this case, it's never, because a notification center publisher simply never emits values, or never emits error values, I should say. If you would have an error type, you can make it anything you want as long as it conforms to Swift's error protocol. Now, once I have obtained this publisher, I can apply operators to it. And operators are simple functions that take publisher's output and transforms it into a new value, just like Swift's map does, for example. In this case, I'm using a compact map. And combine comes with many different operators, but most of them will work very similar to map by transforming an output, or flat map by flattening a level of nesting in your publishers, which I'll show you later in the talk. And there's, of course, tons of other operators, but for now, let's keep it simple and think of it in terms of map mostly. There's also a compact map, which if you return nil from it, you will see that compact map will filter out nil values. Since in this case, I take notifications in and return an optional CG-rect, if I return nil, that value will be hidden from subscribers. And if I emit a CG-rect, then that value will be forwarded to a subscriber. Very similar to how an array that contains nil elements, if you compact map over it, will remove the nil elements. Now, to receive the output of a publisher, you subscribe to it. There are a couple of subscribers in Combine, and the one that I'll be using in this talk is called Sync. Sync receives values and completion events from publishers. It takes a closure that's called upon completion. A completion event means that the publisher is done performing its work and will not emit further values. It can either give you a success with no associated value, or it can give you a failure which has the error associated to it. And once this closure is called, you can be certain that no more values will be emitted by your publisher. The second closure you can pass to Sync, or must pass to Sync really, is the receive value closure. And this closure will receive all values that are published by your publisher. So in this case, it will receive CG-rect instances that represent the user's keyboard frame, right? Because that's what I returned from compact map. And lastly, what you see on screen here is a property called cancelable. Whenever you subscribe to a publisher in Combine, that creates a cancelable object. The cancelable wraps up this relationship between publisher and subscriber, which you can also call a subscription. And whenever this cancelable is deallocated, the subscription is torn down. So if you don't hold on to the cancelable, it will be deallocated as soon as the scope that you're currently in ends, which is often not what you want, because that means that your network calls, for example, are still in flight as your subscription is being torn down. So that's very important to keep in mind when using Combine. So when we know this, and when you've seen this, and you think of functional reactive programming, these statements of it's basically just streams and it's about values over time suddenly kind of make sense. These streams are just the continuous delivery of new values to your subscribers, and values over time mostly means that you are going to receive these values over the course of your application lifecycle. And at this point, you're probably thinking, let's use Combine everywhere. And I would recommend that you do it, or at least try it out, and start with your networking layer. So let's look at a quick example of a network call. Notice that I have a function here called getUserProfile that returns an any publisher. This any publisher is generic over user profile and error. But this is not necessarily the return type that we have immediately. URL session comes with a convenient method called DataTaskPublisher4. And this will create a data task publisher for us that will execute a network request and emit a value whenever the request completes. The type of this thing is a data task publisher, which either emits data or an URL response tuple, or a URL error as a failure. Now I can use Swift's map and then pass it a key path, or Combine's map rather, and pass it a key path to extract the data property from my URL session data task publisher. And as you'll see, the type of publisher that I'm dealing with now changes, because now my data task publisher is wrapped in a map key path publisher. When I apply the next operator, which is called decode, this adds another level of wrapping, and it's very convenient, but this return type is not something I would want to type out. So that's why I close this chain off with a call to erase to any publisher, so that I have a nice return type that I can remember and that I'm fine with having scattered throughout my application, because the other one is just something that I would like to hide. Okay, so that is a very simple data task, and it's very clean in Combine, and I really, really like that about Combine. Now let's look at something more complicated. Let's say we want to log in first and then perform 3 network calls to fetch profile, likes, and friends, and then update the UI. This is something that would be pretty complicated in an imperative environment, but I'll show you how you can do it in Combine. So we would start here by modifying the getUserProfile a little bit, so it really depends on a token being present, which would be good practice in case you would ever have any form of authentication in an app that you're working on. I also wrote a little login method. The structure is very similar to what I did before, so I'm not going to go over it too much. In fact, let's just assume that all of this works very much similar to how getUserProfile worked, and what you really should remember is that these are 4 functions that all return a publisher, and each publisher will emit 1 value and then complete. So if we would want to use this and make this flow that I showed you earlier where we log in first and then make 3 calls, you could write a function, initiate login process, and that function could take a closure. However, that's what you would do normally in the imperative way, and you would probably have all these nested closures, so let's not do that. Instead, we're going to return any publisher. And let me sort of just expand this immediately just a little bit. There's some code here that you're probably not going to understand, and that's fine. Okay, so I have a set of cancellables. This is just another way of storing any cancelable. You can call a publisher's store or a subscriber's store in and then pass it the cancellables as in-out parameter to hold on to the cancelable. Here I have the initiate login process. It returns in any publisher. That creates a future, which is a special kind of publisher in Combine that you can use to wrap some custom async work. Then I call login. I subscribe to the output of login. When we receive a value, I store the token, and upon completion, so when the call is completely done, if there's any failures, I just make my future emit a failure. So that means that it completes with a failure event. And otherwise, I store the token, and I would make calls to getUserProfile, etc., and then maybe use a dispatch group or whatever. And this code would probably work if I would continue, but it's basically imperative, right? It's using closures and subscriptions and all that stuff, which is something I don't want to do. So at this point, you're probably thinking, well, this stuff is still pretty hard, and we're 17 minutes into the talk, and it's really, really complicated, and I'm not sure where we would go with this 4-step process. So it's absolutely essential to understand the building blocks. And when you think of the statement earlier, it's basically just streams. What you should see is something that outputs values, and it enters sort of a stream, right? And this value is transformed along the way into something else. So in this case, we want to take that login process and then stream down and make 3 network calls and stream further down and update the UI. So this right here is really a no-go in Combine. However, do you remember flat map that I showed you earlier? It looked like this. So you take an array of integers, flat map over it, create new arrays, and then you end up with a single array with no nesting. Now we can do the same here for our networking calls. We can call networking.login, which will return a publisher that we can subscribe to. We can also flat map over this publisher. And since the login thing emits a token, we would flat map over the token. And we can return a new publisher from that using that token. And any subscribers will receive a profile in this case instead of a token. Now that's interesting because now we created a publisher inside of the flat map, but it looks like we only had a single publisher. So let's build this feature right here. So what I do, I take my login call, I flat map over it, I create 3 publishers, and then I use Combine's combine latest operator to combine these 3 publishers into a single publisher that will emit a tuple that contains 3 values, 1 for each publisher that I'm combining. And then suddenly here in receive value, I would just get that tuple with the 3 values. And that's all I have to do. In there, I can update my UI. So while this went very quickly, and I can understand if this is maybe too quickly, I want you to see how I used some core building blocks to build something really exciting. And with this, you can really think to yourself, use Combine everywhere. So let's summarize this quickly. Functional reactive programming is built on functional programming principles. It uses pure functions and everything. It's all about responding to changes over time. So that means that not everything happens synchronously. Things can happen asynchronously over the duration of your app. Combine uses publishers to send changes or values to subscribers. And understanding the core building blocks like map, flat map is key to thinking in a reactive manner. When you consider everything as a stream, you will see how you can take a value and send it down a route where it's transformed into other things, and you can build very exciting things with it. So I would like to thank you for listening to this talk. I hope this gave you some insight into how you can think reactively and how you can think in streams rather than imperatively. I know everything went by super quick. So if you want to learn more about Combine, definitely check out my book at practicalcombine.com. I cover all this stuff, and I cover much, much more to help you use Combine in your projects as soon as possible. So thanks again for listening, and I'll see you in the QA.